Okay, Assalamualaikum and greetings. In this video, we're going to discuss some of the questions related to the Alkyl topic. All of these questions was taken from the previous final exam papers, which include section 258 and also section 257. So here we go. For this question, you are given a diagram between an alkyl together with the water molecules. And then let's read the question. A. Identify the chemical structure of all possible products for the above reaction. B. Determine the mechanism SN1, SN2, SN1, SN2, E1 or E2 for above reaction. C. Illustrate the products obtained if H2 is being replaced with OH negative. Outline the mechanism for the reaction into C. Okay, for the time being, we're going to ignore question number D. Kita akan abaikan. Okay, kita nak tengok A, B dengan C terlebih dahulu. Okay, because we're going to discuss the fundamental. Okay, whenever the question start with an alkylate, okay, how do you know it's an alkylate? It must be a carbon which attached to halogen. Okay, in this case, we can identify the structure here. In order to answer such questions, of course, there are 5 factors that we need to consider. However, I highlighted 2. The first one will be the type, okay, the type of the alkylate. Okay, secondly, the type of the nucleophile or the base that we're using. So in this case, we have both items, which is the nucleophile and also the halogen. So let's check back. Okay, first and foremost, look at the type of the alkylate again. Okay, I would like to zoom the structure. Okay, let's identify the CX first. The CX must be the carbon which attaches directly to the halogen. In this case, the halogen that we're using is bromine. So next, okay, let's determine how many carbon attached to the CX. Okay, therefore we're going to get there will be 3 carbon attached to it. Therefore, we can say that this will be a tertiary alkylate. So, for the possibilities between SN2, SN1, E2 and also E1, we can immediately cancel out SN2 because for SN2, it prefers the primary alkylate. So this left us with SN1, E2 and also E1. To confirm the mechanism for this reaction, we need to further check with the nucleophile that we're using. In this case, we are using water. So remember, water is an example of weak nucleophile and base. Therefore, technically, we can cancel out E2 because for E2, it requires strong base. Okay, the reaction of E2 is being affected by strong base. Therefore, it left us with the reaction of SN1 together with E1. So remember guys, there will be 2 outcomes. There will be 2 outcomes of the product. One need to show that the bromine is being substituted. So any reaction involving E1 should be a double bond. So how do we draw the structure? To assist in drawing the structure, okay, for substitution it's quite straightforward because the Br will be replacing by the nucleophile from the reagent. So H2O can be written by as HOH. So for the product of substitution which undergoes in the SN1, okay, we just draw all the number of carbon first. Okay, there will be 4 carbon and there will be 4 carbon. Okay, just to draw it, 1, 2, 3, 4, and there is a methyl group attached to the second carbon. While the bromine, because the name is substitution, we're going to replace the Br with the nucleophile from the water, which is OH. Okay, it must be the negatively charged because it is a nucleophile. So guys, this will be the product of SN1. Again, I want to remind that the product is SN1 and E1 because we are using weak nucleophile. So, what about elimination? In order to draw the elimination, okay, the most important thing you need to know that for elimination product, it should be comprised of a double bond. But where is the double bond will be formed? So, technically, just now, we know that the bromine is located at the second carbon, which means that it should attach, the double bond should form from the second carbon. Okay, as I mark there. Okay, sebab kat situ bromine hilang, kat situ lah double bond kena bermula. So the bromine has the ability to form double bond with the nearby carbon. So it can form with carbon number 1, it can form with carbon number 3, or it can form with carbon number 5. So the idea is it can be either like this one, okay, 1 dengan 2, ataupun 2 dengan 3, ataupun 2 dengan 5. Okay, this will be the structure of the elimination product. Okay, this is product of E1. Remember guys, we have decided earlier the product based on the type of alkyl halide and also type of nucleophile which is weak. Therefore, as you can see, this three structure, but please remember that, let's say I label this as A, B, and C. Structure C and structure A is the same. Okay, structure B, you try to name the compound, I will give you the same name. However, for structure B, structure B will be considered as major based on the side-ref rule. Okay, we already discussed about the side-ref rule earlier in chapter alkyne. Okay, sorry, in chapter alkene. So guys, there you have it. There will be three structures. There will be three structures. Therefore, the marks given, is 3. Because the first question requested for the product form. Okay, identify the chemical structure of all possible products. Okay, 1 for the SN1 and 2 marks for the E1 product. So for C, we can ignore it because it has the same compound just like A, which I have mentioned just now. Okay, there will be 3 marks. Okay, after answering the question, it's pretty easy to answer B because we already determined it earlier. When he said determine the mechanism, so clearly we know that it is E1 and also SN1 because the nucleophile and also the type of alkyl halide, okay, the type of alkyl halide we are using is a tertiary, and we are using a weak nucleophile which support, okay, our mechanism, which is SN1 and also E1. Moving on, okay, illustrate the product obtained if H2O is being replaced with OH. Okay, what happened if we have OH as the nucleophile? So the thing is, I would like to draw back the structure. 4 carbon, a metric group, and also there is a bromine. Instead of using water, we're going to use OH negative. The type of alkyl halide remains the same, which is a tertiary, meaning that it will prefer either E2, SN1, or E1. Okay, we can ignore SN2 because SN2 does not prefer tertiary. Okay, SN2, it does not prefer tertiary. So we can ignore the SN2 option. So now, let's take a look at the type of nucleophile that we are using. In this case, we are using OH, which is a strong nucleophile O base. Therefore, when we are dealing with a strong nucleophile base, we can cancel out SN1 and also we're going to cancel out E1. Therefore, the only option that we're going to get is E2. So E2, remember, we need to form a double bond similar to E1. Okay, similar to E1. The double bond will form between carbon number 2 with the nearby carbon. So if we draw back the structure, it will look like this. Okay, it can be either the major product, which is between carbon number 2 and number 3. Okay, it can also be double bond between carbon number 2 and also carbon number 1, which is the minor one. Again, we're going to follow the side-ref rule to determine which one is major, which one is the minor product. Okay, so this will be the answer. And as you can see here, the marks given is 2 marks. Okay, that will be the discussion for this question. Moving on to next questions. Consider the following reaction. Okay, we have a compound here which is 2-bromobutane which reacted with KCN, and then the bromine has been substituted with CN. It's being replaced. Therefore, we can clearly see without looking at the question, we know that this is clearly a substitution reaction. Okay, so A, the question, predict the rate of reaction if the concentration of KCN is increased. B, illustrate the structural formula for all possible product if KCN is changed to H2O. Okay, let's take a look back at the diagram. So as you can see here, okay, again we're going to identify the type of halide. So this is the CX which attaches to 2 carbon, therefore this will be a secondary. Alright, we can ignore the fact that secondary can undergo all of the mechanism. It can either be SN2, SN1, E2 or E1, because in this question it already given you the product. Okay, so it left with us with this is substitution. We can already eliminate E2 and also E1. Okay, because this is question based on the statement given. So the reaction given is it undergo the substitution process, so it left us with either SN1 or E1. So next step is we're going to take a look at the type of nucleophile or base. So in this case, we are given KCN. Okay, I would like to highlight again. If the compound given, the reactant given, was accompanied with from group 1, okay, from metal from group 1, okay, we can assume that this is strong. Okay, strong nucleophile or strong base. Therefore, between SN2 dengan SN1, which one will have will use stronger nucleophile? Definitely, it will be SN2. Okay, we can ignore SN1 because SN1 only requires weak nucleophile. Alright, let's take a look at the question. Predict the rate of reaction if the concentration of KCN is increased. Okay, for the rate of reaction, rate is given by K, the concentration of Alkyl halides, and the effect by either nucleophile or base. This equation is for SN2 or E2. Okay, this is base. This equation is true for SN2 and E2 because one of the characteristic for this reaction is for SN2 and also E2, it requires strong nucleophile and base. Therefore, it will be affecting the rate of the reaction. Unlike SN1 and also E1, the rate for SN1 or E1, okay, the rate is given by KRX only. It only be affected by the type of Alkyl halide, okay, because they do not need to use strong nucleophile or base. So this is the difference between these two. Therefore, if the question asks predict the rate of reaction if concentration KCN is increased, we knew that, okay, that this reaction was SN2. So the rate for the reaction can be written like this. Rate is equivalent to K Rx multiple with the concentration of the nucleophile. Therefore, if we want to draw the structure, it will be like this. The Rx was this compound, okay, the 2-bromobutane, while the nucleophile is clearly KCN. Therefore, based on the simple calculation, if we increase the KCN, the rate will also increase. Same goes, if we increase the Alkyl halide, the rate will also increase based on the mathematical equation. Therefore, to answer this question, okay, predict the rate of reaction, okay, therefore, the rate of reaction will increase. And then, give the explanation. Okay, why? Because the rate of reaction is K Rx with the concentration of nucleophile. Okay, that will be the answer for the first one. Okay, when it is to predict the rate of reaction. Unlike SN1, okay, unlike SN1, the increase of the nucleophile O base wouldn't affect the rate because SN1 and E1 does not rely on the nucleophile O base. Okay, question number B, illustrate the structural formula for all possible product if KCN is changed into H2O. So let's say we draw back the structure of tributane. For this round, okay, we going to react it with water. And clearly, this is a secondary which can undergo everything, which is SN2, SN1, E2, and also E1. However, when we take a look at water, which is being considered as weak, okay, same like alcohol, we can totally eliminate the option of SN2 and also E2, which left us with SN1 and also E1. So, one product, we should be replacing the Br. So what we're going to replace it with? Okay, we're going to replace it with the nucleophile from the water, which is OH, and the product of the elimination will be the formation of double bond, and based on the Size-F rule, it should form between carbon number 2 and also carbon number 3. So this is the product of SN1 and also E1. Perhaps you'll be asking, okay, is the product of SN2 equivalent to SN1 or the E2 is equivalent to E1? Well, obviously, yes. Okay, both of them will give the same product. You should remember, okay, elimination will produce double bond. Okay, I'm sorry. Okay, the S and 2. Okay, typo there. Sorry, SN1. When we mention substitution, meaning that we're going to replace it with something else. Same goes with the elimination. We should form a double bond between the two carbon. What makes them different is because the pathway of the reaction, where SN2 is bimolecular while SN1 is unimolecular. Same goes with E2 and also E1. One is being considered as bimolecular and the other one is unimolecular. Okay, contoh yang paling mudah lah. Contoh paling mudah macam jalan ke ni lah. Macam eksperimen yang kita buat sebelum ni kan. Dia sebenarnya produk, in the end tu produk yang sama. Yang beza dia adalah jalan. As if we from UiTM we going to go to KL. Okay, we have two option. First, okay, macam tadi, daripada UiTM Tapah, kita nak pergi KL. So, ada two option. Okay, we can either go using highway or we going to use jalan dalam. Okay. Apa tu? Ayolah, jalan dalam lah, jalan dalam. Jalan dalam. So, samalah kalau kita pergi substitution or elimination, it can be either SN2 or SN1. The product is the same, okay, however, the route that we are using is different. Okay, jangan confuse sangat tentang topik ni. And finally, if we take a look at this last question for discussion. Alright, before we even take a look at the question, let's take a look at the diagram. Okay, you are given, in both cases, reaction 1 and reaction 2. Both of them is being using the same compound, which is a secondary Halide, okay, because the CS attached to 2 carbon, so this will be secondary, yang bawah ni pun secondary, and both of them is using water. Okay, water will be considered as weak nucleophile. Okay, so we have secondary, and the keyword here is weak, meaning that we are looking for the SN1 plus E1 product. We're not going to opt for SN2 or E2 because it must require a strong nucleophile. So let's take a look at the questions. Point out the mechanism SN1, SN2, E1, or E2 involved in the above reaction. Therefore, we can clearly predict that it will be SN1 and also it will be E1. The reason why? Because we are using a weak nucleophile. Identify either reaction 1 or 2 occur at faster rate. Okay, the question before I already talking about the rate. Okay, but for this one, remember on the first video I mentioned that there are 5 factors affecting the mechanism of the reaction. The first one will be the type of the halide. Number 2 is the strength of the nucleophile or base. Third is the concentration of the nucleophile and base. Number 4 is solvent, and finally we have temperature. In this case, we are using the same type of alkyl halide and the same type of nucleophile. So, how do we determine which one will react the faster? Okay, that's why we need to refer to the next factor, which is the type of solvent. As you can see here, DMF is considered as what we call as a protic solvent. Okay, this will be a protic solvent. Whilst this is CH3OH is the alcohol, we consider as protic solvent. Okay, protic means that it has OH. A protic maksudnya, okay, tiada OH. So technically, the protic solvent, okay, will prefer SN2 or E2 reaction, while for the protic will prefer it will be SN1 and also E1 reaction. Since both of this reaction is SN1 and E1 reaction, for reaction 1 is SN1 and E1, reaction 2 is also SN1 and E1. The only thing which make them different from one another is because the usage of the solvent. Since reaction 2 using a protic solvent which prefer the SN1 and E1, therefore we can say that which reaction is faster, it will be definitely reaction 2. Okay, again, the reason behind this because it is using protic solvent which prefer the SN1 and also E1 reaction. Okay, the explanation will be in C lah, because it asks you to justify the answer. The only reason is because it's using the protic solvent. Protic solvent, okay, you can read in the slide, is any example of solvent which has OH, such as alcohol, water, and also carboxylic acid. Okay, I'm going to leave you with D. Okay, this is a special case. This is a special case. Okay, you have the option to answer it or not. For the first person to answer D ni, okay, I will give you an extra mark. Provided korang tengok lah video ni, kalau tak tengok. Okay, that's all for our discussion today, for this video. If you have any question, please ask in the Telegram group or leave a comment lah dalam video ni supaya saya boleh jawab. Okay, that's all for this discussion. Okay, goodbye.